Hello and welcome to my video, lesson 6.3 on trigonometry, or SOH CAH TOA. So we are just going to remind ourselves that SOH CAH TOA is with triangles and with right angle triangles only. So first of all, before we even go in any further than that, SOH CAH TOA involves an angle and involves two sides. So you need an angle and you need two sides. Now you could be missing one of these three. You're looking for one of those three, but you have to have two of the other. So when we say opposite, adjacent, and hypotenuse, we're talking about the things that are comparing it to the angle. So adjacent to the angle means next to. Adjacent to the angle means next to the angle. Opposite the angle means opposite the angle. And hypotenuse is similar to, or the same as in Pythagorean theorem, which is 6.2. It's the longest side and the one that is opposite the 90 degree. All right, so with that said, now we have an idea of what this looks like. And this is key. We have SOH, we have CAH, and we have TOA. Each one of these three parts, SOH CAH TOA, shows us or reminds us, helps us remember what we need for any given function. So the most basic function for each of these is if you have the sine, the S, okay, S for sine, sine of the angle equals opposite over hypotenuse. And they're all going to follow the same format. So for CAH, it's cos of the angle equals adjacent over hypotenuse. Cos, adjacent, hypotenuse. And last but not least, TOA, which is tan of the angle, equals opposite over adjacent. So with that in mind, we can now rearrange this to solve for any one of the three values. So let's take a look at sine first in purple. Do we want to solve for the angle, the opposite, or the hypotenuse first? Let's try to solve for the easiest one, which is the opposite. So what we're going to have to do is move the h over to the other side. Right now it's dividing, so we use opposite operators. Opposite of dividing is multiplying. So now we have that opposite equals h times sine theta. Okay, so all we did is moved h over to the other side. And next, we can move we're looking for h, so we're going to move h to the other side. And then we're going to move sine theta over and divide it out. So we're taking that same equation we just had here, and we're dividing by sine theta on both sides. So we have opposite over sine theta. All we're doing here is making different versions of the same equation. We're just rearranging it. And last here we have we're going to be using something called the inverse sine function, which means that it takes the sine and it does an opposite operator. Now the opposite of sine is actually something special called inverse sine. So we're going to be left with theta here, and we're going to be inverse sining on both sides, which cancels out the sine on the one side and gives us inverse sine of opposite over hypotenuse. So those are the three different equations that you could have for sine to solve for any one of those values. With cos, same thing is true. I'm just going to write them out a little bit faster now. So the thing that was on top in the position that O was in is adjacent, hypotenuse times by cos theta. And then the same thing again, adjacent over cos theta. Theta equals cos to the -1, or inverse cos, and adjacent over hypotenuse. So again, these three are the three equations that you could use for cos to find any one of those three values. And now for TOA, we're going to do the same thing again. So O equals A tan theta. A equals O tan theta. Theta equals tan to the -1. Oops. O over A. And those three are the three different versions you can have for TOA. So I want you guys to just pause for a second here and just look at each of these and make sure you understand them. Rewind if you need to, but make sure you understand where you got them all. Because the point is not that you have these three equations memorized per SOH, CAH, and TOA, but that you actually only have one memorized, which is this first one, and you recognize that they all follow the same pattern. They all follow the same pattern. Okay, let's take a look at a question now. Let's make ourselves a triangle. And we're assuming that it's a right angle triangle. And let's solve for, let's find this side here. And we're given that this is 15 and that this is 30 degrees. Okay, so what are you going to do? Are you going to use SOH, CAH, or TOA? So pause it, try it out. Once you have X, press play again. Okay, so first thing I always do in a question like this is try to recognize which side am I missing? Do I not care about? So this side here, whoops, ink to shape. This side here, I don't care about. And that is the opposite side, right? I don't care about opposite. So which one of these does not have opposite? Well, CAH does not have opposite. So then I will put it into our regular form and then move it around from there. So cos 30 equals adjacent over hypotenuse. Adjacent is x over hypotenuse is 15. Then I will move the 15 over to the other side. Was dividing, now it's multiplying. So 15 times by cos 30 equals x. And if you plug that into your calculator, you should get 12.99, or round it up to 13. Okay, so an important thing to notice here is if you're not getting this answer, a very common mistake is in your calculator, you have to be on degrees, which is usually DEG or sometimes just D, shown at the top middle of your calculator. The second thing is some calculators you're able to type it in directly, just as shown. Some calculators you have to be a little bit more careful. When you press the cos button, sometimes it automatically does the calculation. It already presses equals for you, essentially, by pressing the cos button. And that's indicative of a really low-end calculator. So make sure you get this answer. All right, one more question, one more example question here. A new triangle. We're going to be looking for the angle this time. And we know this is a right angle triangle, and this is 3 and 4. Okay, so always pause it, try it, and then press play. For me, what I always do is check which side does not matter to me, and I don't care about the hypotenuse. So which of those three does not have the hypotenuse? SOH, CAH, or TOA? Well, TOA does not have the hypotenuse. So I'm going to use TOA. So tan of the angle equals opposite over adjacent, opposite over adjacent, which is 3 over 4. And now I have to use the tan -1 function. So to move the tan over, and now I just plug it in my calculator, which gives me 36.87. So that is the angle. All right. I hope that this video helps you understand SOH CAH TOA a little bit better. Each of the questions are really the same. The only thing is that it could be asking you for a different part, but that's why I showed you these 3 equations here. I hope this video helps, and good luck.